Okay, so we can keep this session interactive and we'll start this session. So yes, I see Aman also joined. So also I see, yeah, we have more people may join going forward. So let's begin. But yes, I see most of the audience is new. So let me recap about cloud native applications. So have you all heard this term, cloud native applications?
Yes, yes,
Okay,
sir.
okay, yeah. So Madhup, can you just brief about that to everyone, right? What do you understand with cloud native?
The the application which we have to uh, develop, that application should be suitable to cloud. Means that if we are developing the application into local host, and then we are using some of the microservice we are
Yes,
implementing some microservice applications.
yes,
So in that case, that the microservices, and then we are doing the containerizations, and that containerizations, and then we are deploying on a local host. That deployment should happen in the same way onto the cloud. That's where the cloud native application
okay,
was.
okay, very correct, very correct. And can you also tell what cloud? What do you mean by cloud? Is it Amazon cloud, Google cloud, Azure cloud? What kind of cloud the application should be deployed on?
This application should be cloud agnostic.
Okay,
Cloud
perfect.
agnostic means that once we are writing that any microservices on local host, that it can be deployed anywhere. That what all configuration we are making it, like Docker configuration, Docker YML file we are making it, and then that Docker YML file, and that should be deployed onto the any cloud.
Okay, perfect, perfect. Great. So you are absolutely correct. Okay, just a minute. Yes, absolutely right. So the application should be cloud agnostic. And you know what are the languages or frameworks which we should use to build cloud native application? You already mentioned about Docker Kubernetes. What else?
Yeah.
What could be? Can it be Java application? Can it be, what kind of application it could be? A cloud native
It,
application.
it can be any language agnostic. It should not be dependent on any language, or
Perfect.
any framework, if we are going with the Docker or Kubernetes.
Great, great, perfect. So yeah, we have got a perfect definition about cloud native application. Hope everyone understand. Aman and Rahul, Sheikh, any doubts, any queries on that? Fully understand what's cloud native application?
Yes.
Great, great, perfect. Now let's move on to our topics, right? So here, we have to understand few terms. One is cloud computing, right? So what is cloud computing? I'll quickly go because you all understand. Now we see most of the applications, they are deployed on the cloud, right? Uh, and earlier application used to be deployed in your machines. Now even Word and PowerPoint, everything could be used on the cloud. You don't need them to be installed on your local machines. You have them in the cloud, and you can access them through browsers. So that's all about cloud computing. Next thing is what you need for cloud computing. To use any application, you need a browser and the internet connection, and you can use any browser on whatever device you have, whether it's a desktop, laptop, smartphone, tablet. So as an end user, you can consume cloud applications through any platform or any device. So I'll give you some examples of the cloud computing. First is, actually I went through in the last session the complete history of cloud computing. So it started from internet. Internet was a kind of a cloud computing because various institutes, universities, they were sharing static content, web pages, and people can access from anywhere, and they can connect through any site in the network, and then use the content, read the content which is created by any universities and institutes, So that was the starting point of cloud computing, but it was all static pages, right? So all the content was static. So initially this was all cloud computing. Later email came. Email is for communication. And then what next came was various web services. So people can use simple web services to begin with, like weather forecast web service. They can know the weather of any location. So that was simple web services. Later these web services became more complex, and at the same time we got more applications on the cloud. So Gmail was one such application, then Google Docs were other set of applications, and then various other applications came, which were Google Drive, desktop, Google Dropbox, etc. So this was a kind of a brief starting point of cloud computing. Okay, just a minute. Yes, great. I'm just admitting other people. So Sanjay, yes. So we were just going back through the recap of previous session. So we learned that okay, we got various storage computing, and then we'll discuss more about these going forward. So going to next slide, what are the benefits of cloud computing? So why do we need to run the application on the cloud? Because we understood from Madhu that you need cloud computing, and with cloud native application you can deploy applications on the cloud. But the benefits, what are the benefits? So the benefits are cost saving, flexibility, reliability, and productivity, right? So you can share, collaborate on the same document. That's how the productivity is increased. Reliability is definitely, the cloud servers will be more reliable because they will be managed by experts. And flexibility, because you have the ability to scale up and down based on what is the load which you want to serve. And then definitely cloud also provides cost saving, because if you have to run any application on your premises, you have to purchase the hardware, and if you need to serve many people, hundreds of people, you would need expensive hardware. And with cloud computing you get services on the subscription based model, right? So everyone understood the benefits of cloud computing? Any queries, any other inputs on this benefits? Anything more you want to add, if something I have missed out?
Yeah, one thing, Tarun, what I can say that cloud computing, why do we require it? Because it provides the on-demand resources. We don't have to purchase it, and we don't have to keep it just like a isolation. Okay, we whenever we require to use the resources on that basis on demand, we can use it, and then we can shut it down so that we can save the cost. Yeah.
Okay. Yes, that's a great point, because resource sharing, right? So I discussed this in the last class also, that earlier when you used to have on-premise applications, what you need to do is you need to run only one application on the particular device. Because say for example, if you want to run an Oracle database, you will run only Oracle database on that particular server. And if you want to run some other application server, say Tomcat application server or HTTP server, Tomcat is an HTTP server, so just correction. So you need a one separate server for running this HTTP server, and you don't share this machine for other purposes. The reason being, if you are running any application in the production, and if there is any conflict between any other applications which is running on that particular system, you will not get the performance. So for improved performance and for reliability reasons, so that you don't accidentally mess with the existing applications and environment, you use dedicated machines. So gradually industry progressed from dedicated machines to virtual machines. Virtual machines are machines where you have a hypervisor which is managing different virtual machines, and each virtual machines are running separate operating system. And now the latest innovation is Docker containers. With Docker containers, you can have lightweight virtual machines. Docker containers are isolated boxes, uh, isolated environments. They act as a virtual machine, but they are very lightweight because they don't contain their operating system. So you don't have a separate operating system running on a Docker. It only has a small kernel which is sufficient to manage the environment which is running within the Docker. So this is about the Docker containers, and now this is about also resource sharing. So you should understand that as the industry started, they were first using dedicated resources. Then they wanted to utilize the same resource for multiple purpose, because reason could be that at one moment of time, say if you are running payroll application, you'll only need more load towards the end of the month. But yes, throughout the month you will not have that load, so you can use the same hardware and use it for some other purpose and run other applications. And since you have virtual machine, you have a sandbox, and you will not mess with the environment or setup of that particular application, and you can be very sure that next time when you start the virtual machine, it will exactly be the same environment as previously, and your performance and various other application reliability factors are exactly the same as it was before. Understood this point?
Yes.
Perfect. So now let's come to various types of cloud computing. So cloud computings are of three different types. One is the public cloud, and other one is private cloud, and the hybrid cloud. Public cloud everyone understands. For example, Google Docs, Gmail, or say OneDrive. These are applications which are on the public cloud because anyone can access them. What you need is just an internet connection, and you have to sign up, and then it's available for everyone in any locations, right? So this is public cloud. Can someone explain what is private cloud? Any idea about what is private cloud?
Yeah, I can say that, but may I? Yes, I can explain.
Yes,
but
no problem, no problem. Go
yeah.
ahead.
See, cloud, which can be dedicated for the organizations. Means that the cloud, it can be. Suppose that if we are going for the AWS cloud or GCP, we are going it.
Yes.
So we have to just we have to connect to our DNS, whatever company organization DNS is there. That DNS we need to connect it to the VPN or some other security
Yes.
security providers. That way we can make this as a private cloud for that organization.
Okay. I would say still it's not a complete private cloud. It's a VPN network, right?
Yeah, it is.
Because
Yeah,
your cloud infrastructure is located in Amazon or Google and is managed by Google and Amazon, right? So what you have is a kind of a, I would say it is also like a hybrid cloud, right?
yeah, it
You
can
are
be.
using
It can
the
be hybrid.
servers within your organization, and then you are also using the servers which are outside your organization. So that's exactly hybrid cloud. Private cloud is a cloud environment. So what Amazon is doing, what Google is doing, they are having data centers, and they have multiple servers on the data center. They have rack servers. Rack servers are the latest technology. So you have a kind of a almirah of servers, and you have various servers which are racks, which will be inserted into racks horizontally. So this provides a very space efficient way of running multiple servers in small space, right? Because if you run any server, you need to have a office or a server lab where you will be running these servers. So you need real estate cost, right? Because you need to have that room where you will place the servers, and you have to put the ACs, you have to put the power connections and generators, or no, you have the power backup required also for that. So you need to put a lot of investment. You have to put some security on that so that no one can access it, and you have to take care that ventilation and other maintenance activities are there ongoing on regular basis, because you have to avoid dust, etc. Right? So these are various things which needs to be required to be done to run a data center. And Google, Facebook, they have multiple data centers all across the globe, and for every region they have different data centers. If your organization starts doing the same, and Amazon and Google are using the data centers for their services as well, and they are also providing it to other enterprises or individuals who want to use the computing resources. But in a private cloud, you do it only for your organization. You do not provide it as a service to other organizations and enterprises. So it's a dedicated data center which is running for your organization, and in which you will host your applications, and its application will be used by your employees only. So this is private cloud. Understood?
Yes, Arun, understood.
Correct. Now next thing is a hybrid cloud. Hybrid cloud is, you have private cloud, but assume you need more capacity, right? So what you can do is you can utilize a public cloud and have some application which can be running on your private servers and on public servers as well. Maybe I can have a application where all my users from India, they will be served from the private cloud, and some other location, say US, when their users are accessing the application, they will be accessing it in maybe from GCP cloud. So you have both kinds of servers which are serving the application, which is in the private cloud as well as on the public cloud. This mechanism is called hybrid cloud, right? So there is another term which is called heterogeneous cloud. Heterogeneous cloud is you may have different kinds of cloud environments. For example, you may use AWS, you may use GCP, and same application may be running in Azure, in AWS, and in GCP at the same time, right? And you are just doing some load balancing from these different applications, right? Is it possible?
Can you please repeat again?
So I'm saying, can we have an application which can be running some servers on GCP, some servers on Azure, and some servers on AWS?
Yes, it is possible.
Right, definitely. No, so yes, because as you are doing a cloud native application development, you can have the same kind of components hosted on different cloud servers, or you can do it like this, that maybe storage you use from AWS S3 server, but compute resources you may use as a Google Cloud Engine, GCP. So yes, you can integrate, have an application which is running across multiple clouds, but then you have to deal with performance issues, because within the same kind of cloud you will have a fast dedicated connection. So if you use Google computing resources, then you use the Google storage as well. That will be more efficient. But for some optimization, for some other specific reasons, you may have applications which could be running across multiple clouds as well. And definitely you could be running some components on the local machines or private clouds. So that's also possible. Great. So is this clear to everyone? They understand what's an in-premise application, what's a in-cloud application, and what is a public cloud, hybrid cloud, and private cloud. And then I also introduced another terminology, which is heterogeneous cloud.
So Rahul here, I just have one confusion on
Sure.
private cloud versus on-premise.
Yes.
So on-premise also the motive is that the deployment is under your control,
Correct.
and while the private cloud sounds like in a similar way we are doing that. We want the deployment to be controlled by us, and we don't want to share the services to others.
Yes. Right.
So we
Same.
decide on that scenarios.
Yes, right. So only difference is the architecture of the application. So on the private cloud, when we say cloud, this means you have different kinds of cloud infrastructures, right? So the application is designed in a microservices way, and it is available for everyone as a cloud service, right? So this is about the cloud applications, but on-premise applications are not available as a cloud application to everyone. They may be, only limited people may have access to it. They may require using some client also. So you may have a Java Swing based clients, and you may have various mechanisms to access it. It may not be just browser based cloud kind of setup. But in a cloud, private cloud, what you have is you have resources which are generic, and you can utilize it. For example, AWS you can utilize for anything. You can utilize it to run a web application, or you can host maybe a backend of a mobile application, or you can do some data crunching analytics using AWS. Same way, your private cloud is a infrastructure which is available within your organization, and it is available for various IT teams within your organization, and they can run whatever they want on these cloud. But whereas for on-premise application, you purchase a server and then you run that particular application only, and you don't have that flexibility as you have in cloud, so on private cloud.
Sure.
Correct. So that's difference is not just about the ownership and who is maintaining the environment, it's about the architecture.
Sure.
So yeah, on-premise is not cloud, it is just an application running within your organization. But private clouds are clouds which is almost same as AWS. You can do anything on that. They are kind of a development environment. They can be used like that, or they can be used to deploy productive applications. So this is the difference. Great. So yes, definitely Java is one of the most popular language to build cloud native applications. And yes, I already talked about the evolution of cloud computing, that we started with the World Wide Web, then we got various services which were like email services, which were also kind of a cloud computing applications. And then there were web services which were available, like weather forecast. And then as the web services became more complex, there was a protocol which came, which was SOAP protocol. So now it's very less used because of the complexity, but SOAP was a XML based protocol which was used for communication between different servers. And first company which introduced cloud computing was Salesforce.com. They came up with a CRM solution which was completely on the cloud. So earlier popular CRM services like Siebel or Oracle or SAP, for running these you need in-premise mode. So you have to purchase a server as per their server requirements, and then install these heavy applications from SAP or Oracle. And once you have all these applications set up, you have to ask your end users to install some client application. In case of Oracle, there was or Siebel client was there. Siebel got acquired by Oracle, so it became Oracle CRM. But yes, SAP had a SAP UI or SAP client, which was called SAP GUI, which was a kind of a client, Windows client, using which you can connect to any ERP system or a CRM system and can work with this. So this was how it was done without cloud. But with Salesforce, now in around 2000s, early 2000, they came up with a CRM system which was almost like browser-based CRM system, like you have Gmail, like you had at the time Gmail also. Gmail also came around the same time, and other emails were there, which was Hotmail, and so they were all browser-based applications. Yahoo Mail also was one of early email clients, email applications. And on similar lines, Salesforce came up with their CRM applications, right? So this is first generation of cloud applications, and now definitely Salesforce is still in existence. Anyone knows the trademark for Salesforce? What's their punchline or tagline? So the tagline for Salesforce is "No software." They also use that as a logo. They write a kind of a traffic board with software written, and then like no parking sign, you have a cross. They have this "No software" logo, and their tagline is "No software," because if you are using CRM on Salesforce, you don't have to install anything. You just have to access the application through your browser. So you don't need to purchase any costly hardware. You don't have to run and deploy your applications on that in-premise mode. And then on the client side also, you don't have to do anything. You just ask all your users to install browsers. And now this model is being copied by many other companies. For example, now SAP Cloud is there, Google, Oracle Cloud is there, and from Microsoft, Dynamics is another cloud application, which is an enterprise application, which is a CRM application, and various other suites of applications are also there, which can all be accessed on browsers, and users only need to pay a subscription fees, and they use the application on browser without installing anything other than the browser on their operating systems. Clear? Okay, so let's move on. Right. So now let's come to cloud native applications again. So cloud native applications are applications that can take advantage of cloud computing, because to take an advantage of cloud computing, as we just discussed with Rahul about what's the difference between on-premise application and a cloud application, because it's a difference is in the architecture. Generally, the on-premise applications are monolithic applications, as I explained about SAP applications and Siebel applications. They are not running microservices architecture. They are mostly monolith application. They have a central database, and the company, they have to manage the database, they have to manage the servers, and you may have multiple clusters of these applications, but still scalability is limited because your database could become a bottleneck. And in a cloud native application, you design it as a very scalable cloud applications, and you can break the application into microservices. So as I was talking about, I gave an example of Salesforce, which was the first generation cloud application. Later, Amazon internally utilized cloud for hosting the e-commerce application, which Amazon was serving to many countries, and also they came up with this microservices architecture. So microservice architecture was something which was earlier adapted by Amazon, and there were few conferences where this was discussed, and then the terminology cloud native application came into. So as we already discussed, it utilizes Docker and Kubernetes. Now I will come back and will also understand the concept. Why do we need Docker or Kubernetes for running cloud native applications? Correct. So anyone wants to take this? That what is the use of Docker and Kubernetes? Let's start with what is the use of Docker, and now how it helps in making your application cloud native.
May I speak or?
Yeah, carry on. Yes, you should. Definitely.
Here, once we are using a Docker, so Docker basically runs on the Docker is subset of VM, we can say, and
Yes.
here we don't require we only require the application to deploy it there, and this application can be from the any language. It cannot be depend on the some language. So in that way, that Docker helps that the Docker helps to run the application in microservices environment. So this to running the application, we require the Docker YAML file, and that Docker YAML file will do that. What all containers we require on the basis of the resource utilizations.
Yes, perfect. Yes, definitely. The first thing is when you want to run any application on cloud, you have to deploy it into multiple servers. So that's very important requirement, that if you want to make any cloud native application, you should be able to replicate that application into multiple servers. So one way to do it is manually doing it, but that will not be scalable, because you also want to automatically deploy the application as the load increases. So Docker provides you an environment which is kind of a sandbox environment, which you can replicate any number of times, because when you replicate a particular environment, you have to have the dependencies, you have to have some core components which are needed to run the application. Say for example, if you want to run a Java servlet application, or a Spring, let's take an example of a Spring Boot application. So if you want to run a Spring Boot application, you will need Java virtual machine on the system, and you will need the Spring Boot. Spring Boot comes with pre-packaged server. So Tomcat, it could be pre-packaged onto Tomcat, or you can deploy your Spring Boot applications jar or var into any of the standard Java application server. So that's the requirement. But then you may also use some third-party libraries, so which also needs to be deployed into the server. There could be some runtime dependencies that you have to take care. You may have a database, so you need to take care of deploying that database, and there could be several other components as well. So it becomes a very hard for complex or sizable application. It becomes a very hard task to replicate the same environment again and again. And while doing this, you would have to also configure the database, connect it with the application server. You have to open the same port, and your application will be expecting some inputs on some port. Some sockets, some connections have to be open. So there are a lot of things involved in deploying an application, and to manage them all it becomes very difficult if you want to do it manually. Docker provides a way where you create a Docker file, and in which you can write a simple script how to build that Docker image, and you have very simple commands. So I would recommend everyone to try Docker. Go to the Docker website, docker.com, and install the Docker runtime into your operating system. So if you are using Windows or Mac, you can install Docker on your machine, and you can start creating, say for example, a Java runtime on Docker, and this way you can stop and start Docker containers, and these containers you can share with anyone. So this is a very good way of sharing your application with other one, because other person what it needs to do to get the setup done, you just have to take the Docker image. So you can share Docker images in Docker Hub, which is similar to GitHub, but this is a repository for Docker images. You can publish your image and let anyone use it. So they may get, say, the LAMP stack, or they may get your Java runtime, which requires maybe, say, MySQL and some Tomcat, Jakarta Tomcat application server, or no other components, which may also involve some proxy servers like Nginx or web servers for sharing HTML content. So you can share entire application in a very easy to replicate way, and the other person just can run these Docker commands, which gets automatically executed from Docker file, and he'll get in one step or in few steps the entire environment ready. So is this clear about the benefits of Docker? So not only this, you can create multiple Docker components, and you can create completely a kind of a network using Dockers, because you can not only just run one Docker container in your machine, you can run multiple Docker containers in your machine. So for example, if you are working on some application, say it's a web application, you may need a database. So you can create a Docker container with MySQL database. You can create another Docker container, say with JBoss application server, or Tomcat Jakarta application server, or and then you can configure these two Docker containers to connect to each other and share information between each other. So this way you have an application server running with database as a backend, which could be used as a storage, right? And you can persist data in that storage. And same way you can connect a web server, HTTP server, which can serve the HTML pages, and you can host a React application. So this way you have a multi-tier application where you have a front end which may be running Node.js, you have a back end which may be running some services which are written in Java, and these services are exposed as REST APIs, and your React application is consuming these REST APIs, and these REST services will in turn connect to the database. So this application requires three components, and if you want to share it with some of your friends and colleagues, they have to follow a lot of steps, because they have to install the web application server, they have to install the database, and also they have to connect all of these components. So if you share them as a Docker container, then they can very easily replicate it, and instead of spending multiple days to share the same environment and replicate it, you will just need few minutes. So this is the benefit of Docker. Any queries on this? Okay, great. So attending these sessions live, that's a big benefit, that you can ask questions and we can discuss. So use it to discuss and share any insights, because many things I may not be telling, but that may come to your mind. So never feel shy to share any thoughts on these. So this is about the Docker, and then next thing is Kubernetes. So can anyone explain about Kubernetes? So Madhu, you want to talk about Kubernetes?
Yeah.
Sure,
Kubernetes,
definitely.
what I can say that it is a Docker orchestration platform or Docker monitoring platform. We can say that a Kubernetes.
Yes.
Okay. Kubernetes, we can verify that how many Docker container is running, what is the status of the
Yes.
Docker container. There's all verifications we can do it to Kubernetes.
Yes.
Kubernetes also provides that service. There are different component in the Kubernetes like the pods.
Yes.
Pods is there, service is there, replica is there, that are managing at the whole Docker related thing inside of the Kubernetes platform.
Yes. Yes. Right. Correct.
And through Kubernetes also routing can be also provided. Okay, so in that case, how the routing can be done on the done inside a pod. That pod is nothing actually. It is basically container.
Right. Right. Absolutely. So, yeah, good point. You shared nice insight about Kubernetes, but just fundamentally, I talked about that. Okay, you need multiple Docker containers to run some applications. So we discussed that. But what if you shared your application and it requires 3 Docker containers? What if your friend forgot to run one of the Docker container? Now the application will not run, because if you don't have the backend server, we'll just get the blank web pages when he run the React applications. Or if the database is not there, then no, the REST API, when he will be calling with his REST React client, he will not be able to fetch the data. So this is what problem it can happen. So you need orchestration platform which can ensure all the Docker containers which are there in the dependencies are there, and you can manage them. Because what if your person colleague who replicated the environment, he did it all correctly, but after some time one system crashed, say database crashed and stopped, the application will stop running, and this is what you don't want, right? Because your application is a kind of a cloud application and you want it to be running all the time, and different components, they will fail. Sometimes your web server will fail or your HTTP server will fail. That can happen many times under many situations. So you cannot ensure that they will always be running, but what you can ensure is you can have a mechanism in case one system goes down, automatically you can create another Docker container and you can read out the traffic to the other Docker container when it is running. Or what if when there are multiple requests coming, you can replicate some of the layers independent of each other, because you may be able to run more backend services if many clients are connecting. So depending on the load, you can replicate selective components. So that's called orchestration, where you are managing multiple Docker images, and this is done all automatically, right? So this is about why you need Kubernetes. There is another parallel technology which is Docker Swarm. It's very easy to use. If you deploy Docker, I will advise first to prepare some simple environment in Docker locally in your system. Then go one step. Try this service which is Docker Swarm. I'm not sure, maybe if it is now obsolete, you may not get it, but yeah, just see if it's still available in the version where you are trying it. And play around with Docker Swarm. Docker Swarm is a service which is exactly similar to Kubernetes, but Kubernetes is more powerful and nowadays more popular. So then once you have tried out Docker Swarm, you can learn Kubernetes as well, right? Maybe I'll cover in next sections all these technologies. But yeah, for right now, no, you can just play around, do some simple experiments with these containers, and then you will gain what are the benefits of Kubernetes. Now, one more thing is Kubernetes is also available in service as a service in all the cloud platforms. So whether you are running AWS or you are running Azure or Google Cloud Platform, and there are many other platforms like Heroku and Oracle Cloud, SAP Cloud, IBM Cloud. So there are so many cloud providers. Most of the cloud providers, they support Kubernetes. So if your application can be deployed and orchestrated as Docker containers, and with orchestration done with Kubernetes supports Docker. So they work together very well, and nowadays that's the only runtime which is supported by Kubernetes, Docker. So all the pods could they can only be Docker containers. So you can have this kind of architecture, and if you have this components, then you can very easily deploy it in any cloud also. So you can deploy it into local machine, and you can also deploy it into any public clouds as well. And since your private cloud will also be very similar to the public cloud, you can also deploy it in private cloud, and it can also work in hybrid cloud mode. So yes, I would give you all one exercise. Assume you have to design a private cloud. So what all you need to design a private cloud? So you have to come up with, think about what all is required to run your own cloud. Or say other way, assume you have many laptops or servers at your home. You want to provide a cloud service like AWS, right? So what all you will need to provide such service like AWS, right? So maybe you can give do some research on this to understand what all is done by Amazon, what all is done by Azure and Google Cloud to provide the infrastructure as a service to so many people all around the world. Right. Any queries, questions, anything, any inputs? Am I
No questions. No
going too
questions.
slow, too fast? Anything? Sheikh and Rahul, how are you feeling with the speed? Is it good?
Yes, sir. For me, these are new things, so
Correct.
going good. Sir.
Okay. Because if you are understanding the concepts, then it's good, because if you have any doubts or queries, don't keep yourself with that doubt, because that will block you to understand more concepts. And feel free to interrupt me and ask the doubts. This way, the session will become more valuable, interactive for everyone, and this way you will get the maximum benefit as well. So now, next thing to research on. I assume, are you all Java developers?
Yes.
Right, so Rahul is, how about Sheikh? You are also Java developer? So I think, most of the people, they are Java developers, because whoever I have been, many people who I've been engaging with, I have found maximum amount of people are Java developers. Very few are, say, C#, and very few are using any other technologies. Maybe some are using JavaScript and iOS. But if you want to develop a microservice in Java, now what you need to do, right? One option is you can create a microservice using a Spring Boot, right? Spring framework. The other options are, there is another latest framework which I have mentioned, microprofile. So do a research on microprofile. It's a more standard based approach, and it's more advanced framework for building microservices than Spring, right? So this is something I would like everyone to try it out. Create a simple REST services in microprofile, right? So Madhu, have you heard about microprofile?
No, no, I have not heard this. First
Okay.
time I'm
Okay.
hearing. Yeah.
Right. So I'll give you a little bit background or history about microprofile. This framework came around 2016 or 2015. Exact year I don't remember, but around that time. So Oracle was responsible for Java and Java EE development as well. But then few people felt that they need a framework like Java EE for developing microprofiles. So what they do is they took the existing Java EE framework and they felt that okay, there are gaps and it do not provide all the features which they need for building microservices. So they created more standards on top of Java EE, and they called it microprofile application. And this framework was also available as an open source framework, and it was managed by Eclipse Foundation. So this is about the microprofile framework, and this focuses on developing microservices and is converging with Java EE. So now Java EE is known as Jakarta EE because now Oracle has donated it to Eclipse Foundation, and it's more open source. So Spring is converging and is now getting themselves compliant with Jakarta EE. Hibernate is getting compliant with the Jakarta EE, and all the frameworks, they will come under the same umbrella of Jakarta EE. So now the Java EE has kind of become more powerful and more standardized and more open source friendly, because now there is no single vendor who is controlling everything. So this is an advantage of using Jakarta EE and using microprofile. So this is some latest technologies you should try for building REST applications, which will be more feature rich and more powerful than Spring, and definitely will be more stable and more high performing, because they are designed for microservices specifically rather than for entire suite components. For example, Spring has MVC component, it has REST services, it has database connectivity services. So a lot of services plugins are there for Spring. So you should look into microprofile framework, and I'll go into details of various facilities which are there in microprofile application. So I think with microprofile I will stop the presentation now, because now it's already the time, 1 hour time which we have already spent. So otherwise it will become very heavy. So let me just complete this last slide, and this is you should know about that examples of cloud native applications. So these are the modern applications. I talked about one modern application which was Amazon, right? They are utilizing the cloud. Definitely Salesforce is also utilizing the cloud, but with respect to scale, Amazon's scale is much higher than Salesforce. And definitely the other scalable applications are Netflix, Airbnb, Twitter, Facebook, Instagram, Pinterest, Uber, right? So these are doing these applications are doing really well, and you would have never felt a situation where these applications are down or they are giving you wrong input, inconsistent data, right? Have anyone faced a situation where he is unable to access these applications, or they are not giving you fast response or inconsistent data?
One question, Tarun, here. So you are talking about only Facebook, or you are talking about all the applications?
All the applications, any of these applications, they are all very good applications, right?
Yeah, yeah. But I've seen that some of the application they will not give that they will not give that consistent data. Facebook will not give the consistent data. It will sometimes it will give the inconsistent data also.
Okay, give an example.
Uh, uh, Suppose that if you are seeing some news, you have that then okay some news feeder you have made. The actually it is not the current news. It is showing it. It is for last 7 and 8 days old news. Also, it will show on the first page itself.
Yeah,
Okay.
yeah. Okay,
Yeah.
okay. Yes.
And
Right, right. I agree. Sometimes they will, no, not be showing conditions. I will give you some more examples. For example, sometimes, no, when you update the profile, when you update your profile pic, it may not very immediately available to everyone, right? So there may be some delay when you update your profile, or sometimes it may happen that number of likes, it may be showing old data, slightly old data, which is older than few minutes,
correct.
or number of views. There could be some differences, and sometimes the content could be irritating, and it may not be something which you are interested in, right? Totally absurd.
Correct.
Maybe I will
Yeah.
get some French or other language, right? If I'm accessing some say for example from Bangalore, an application from Facebook application from Bangalore, maybe I sometimes unwantedly get some content which is in the regional language, regional news channel, or something which I'm not interested on. So that is something also I will consider as a problem with the application. But as such, there is no major problem. These all
Correct.
problems you will see, and then after some time it will all go away. But there is nothing like you will see a crash, or the applications are down, and Uber, you can trust, you can go to any place and then trust Uber that you will get a cab, right? If there are good amount of cabs available, it will never happen that okay, you went somewhere and then you find out the Uber app is not working and you get stuck, right? So there could be some other reasons, because maybe the drivers are not there. But in case drivers are there and you are going to well-known location, Uber will work, Pinterest will work, Instagram will work most of the time. It will not happen that okay, video is loading forever, and then you see the video cannot be loaded, right? If you have good connectivity, you will get the video, you will get the Twitter feeds, you can search with the tweets, and you will get good results also most of the time. But yes, sometimes it may not give you, but still the stability is very good and best in class in the industry. So yes, we'll talk about the architecture of these all applications and what all components are required to build them as we'll go along, and we'll dive also deeper into various Java technologies which will be used or which can be utilized to build a very production quality microservice. Whatever is the best in class microservice possible, we'll do some hands-on and play around in the next sessions. Great, so that's all for today. We'll see you next time. Perfect.
Yes, Tarun.
Good. See you then. Thanks a lot, and we'll dive deeper into other topics next time, and let's meet up again next week. And
Sure, Tarun.
I'll
Sure.
share the invite earlier so that more people can join, and we can have a bigger set of people who can discuss and talk about various aspects. So I'll try to get more people, and you also feel free to share this group with anyone, your colleagues and friends who may be interested in attending these sessions. And all these content, what I am sharing is from one of my upcoming book on building microservices using Java applications. So I'm writing a book on cloud native application development using Java, and in particular microprofile frameworks. And also that book will talk about how to deploy these applications using Kubernetes and Docker containers as well.
Sure.
Great, great. See you. Okay, bye.
Thank you so much. Thank you.
Okay, Tarun. See you. Bye bye.